8086 microprocessor emulator, also known as EMU8086, is an emulator of the program 8086 microprocessor. It is developed with a built-in 8086 assembler. This application is able to run programs on both PC desktops and laptops. This tool is primarily designed to copy or emulate hardware. These include the memory of a program, CPU, RAM, input and output devices, and even the display screen. There are instructions to follow when using this emulator. It can be executed into one of the two ways, backward or forward. There are also examples of assembly source code included. With this, it allows the programming of assembly language, reverse engineering. Interface of 8086 microprocessor emulator is simple and easy to manage. There are 5 major buttons with icons and titles included. These are load, reload, step back, single step, and run. Above those buttons is the menu that includes File, View, Virtual Devices, Virtual Drive, and Help. Below the buttons is a series of choices that are usually in numbers and codes. At the leftmost part is an area called Registers with an indication of either H or L. The other site is divided into 2, which enable. Nowadays, most of us are familiar with various technical languages such as C, C++, Java, or Python. But other than these languages, there is also a low-level language called as assembly language. It's designed to make specific processors work. One of the processors that the assembly language can program is Intel's 8086 microprocessor. It was designed in 1976. It's a 16-bit microprocessor with 20-bit address lines and a 16-bit data bus. And it also has a memory capacity of 1 MB. So, to make the 8086 microprocessor display Hello World on the output screen. Model small. With model small you get a program where CS points to a segment of its own, followed by the segment where DS and SS are pointing to. The stack is placed in the highest region of the SS segment. ORG100, org, address. For origin is an assembly directive, not an instruction. It defines where the machine code, translated assembly program, is to place in memory. As for ORG100H, this deals with 80x86 COM program format, command, which consists of only one segment of max 64 KB. 100H says that the machine code starts from address, offset, 100H in this segment, effective address is CS100H. For COM format the offset is always 100H. Code define the stacked data and code segments, respectively, and specifies the end of the assembly process. On the main module, or if a single module program, it contains a label identifier that indicates the execution start proc near. There are 2 types of calls in JMPS in 16-bit assembly, near and far. Near contains a 16-bit offset. For calls it will save the IP only. Far contains a segment and a 16-bit offset. For calls it will save IP and CS. Defining a proc as far tells the assembler that all calls to that proc must give both a segment and a 16-bit decibels. Syntax for a variable declaration. Name dB value, dB, stays for defined byte. Name DW value, DW, stays for defined word. Name can be any letter or digit combination, though it should start with a letter. It's possible to declare unnamed variables by not specifying the name. This variable will have an address but no name. Value can be any numeric value in any supported numbering system, hexadecimal,